Okay, so this is section 6.6. We kind of skipped around, so I'm just going to go back and fill in the examples that we skipped around on. So I didn't do example 6 in class where we were trying to rewrite an I raised to a higher power using I to the first equaling 1 and using I to the second equals -1. So these are some powers of I that I know are true, and I can use these to rewrite these higher powered i's so that they are much simpler. So meaning I'm going to rewrite them so that they end up equaling 1, -1, I, or -I. And the reason why I want to try to get one of those 4 answers is because the powers of I, they start to repeat after you have I to the first, I to the second, I to the third, and I to the fourth. So basically, I to the first is always going to end up being I to the second is going to be -1, I to the third you can create by using I to the first and I to the second, and I can create it, so let me do that off the side. I can create that I to the third by rewriting it as I to the first times I to the second, because when you have the same base, you add the exponent. So I have the same base I would add the exponents 1 plus 2 to give me I to the third, so these are equivalent, and now I to the first is just going to stay I, but I to the second I can replace with -1, so really I to the third power is really -I. So that is really going to be -I. I to the fourth is going to end up being 1, and here's why. If you have I to the fourth, you can rewrite that as I squared times I squared. Again, same base, add the exponents, which is the same thing as saying -1 times -1, which is 1. So after this, I to the fifth starts repeating. I to the fifth would end up being I, because it would be I to the fourth times I to the first, which is 1 times I, so it ends up being I. I to the sixth becomes -1, I to the seventh, I to the eighth, I to the ninth, I to the 10th, starts repeating in a cycle of 4. So that means any power of I would always be one of these 4 terms. So that's our whole purpose here, is to take something and reduce it so that we get one of these 4 original terms. So when I'm looking at I to the 30th, the technique to help us reduce this was to rewrite this 30 using I to the second, just because I know I to the second is going to be -1, and it's easy for us to figure out -1 raised to any power. If it's raised to an odd number, it's going to stay -1. If it's raised to an even number, it's going to become +1. So by using -1, or by using I squared, it's just going to allow us to use -1, which is easy for us to evaluate. So that's why we pick I to the second. You could use I to the fourth. So if you've done it before, you might have used I to the fourth. That works, but when it's easy for us to figure out multiples of 2, that's probably easier than multiples of 4, so that's why I'm using I to the second. So for I to the 11th, I want to rewrite this as something with I squared in it, and I know that 2 times 5 is going to give me 10, so I'm going to use 2 times 5, or 2 raised to the 5th. So this would give me I to the 10, but I have one more that I need in order to get I to the 11th. I need to add 1 to the 10th power. So in order to add 1, you'd be multiplying your i's so that you can add the exponents. So these 2 things here are equivalent. So that means this is going to be -1 raised to the 5th power times I to the first is just I. -1 raised to an odd power has to be -1 times I is just going to be -I. Then I look at the next one, I to the 40th power. So Again, try to rewrite it so that you have an I squared so that you can replace